Let's have a look at this question here. So we have a curve here, which is y equals f of x, which is equal to sine 2x over minus 3 plus cos 2x between the interval of 0 and pi. So we have a minimum point at P, which you can see on a diagram, and a maximum at Q. And it says show the x-coordinate of P and the x-coordinate of 2 as solutions of that equation there. So let's think about what we know about the x-coordinates of P and Q. Well, we know that they are the turning points. And what do we know about turning points? We know that dy by dx will equal 0 at the turning points. So if we basically sub in the x-coordinates of P and Q, so x-coords of P and Q, that will make dy by dx 0. So what we're basically being asked to do for this first part is to differentiate the curve, set it equal to 0, and show that it will equal that, because that would give us the solutions where the x-coordinates of P and Q would be the solutions to those equations. So let's have a go at that. So there's our f of x at the top there. So I'm just going to call it y, because we're probably a bit more used to seeing that notation. So it's equal to sine of 2x minus 3 plus cos of 2x. Now, when we're differentiating here, because we've got a fraction, we are going to have to use the quotient rule. So I'm just going to put it on here, the quotient rule. So I just write in terms of u's and v's. So it starts with v, first derivative of u, minus u, the first derivative of v, all over v squared. So now what I always do is I just define what all those things are, just to make my life a little bit easier. So u, for quotient rule, u is always the numerator and v is always the denominator. So that's u. The first derivative of u will bring the coefficient of x in front, and then sine differentiates to positive cos. So it will be 2 cos 2x. And then v is minus 3 plus cos of 2x. I'd normally write v underneath, next to it, but I'm going to have to write underneath. I'm going to run out of room. So minus 3 will differentiate to 0. And then cos differentiates to minus sine, but we've got to bring that 2 in front as well, which is minus sine 2x. And you can check that using chain rule, but if you're happy with that, then we can just do that. So we have this now. So we now put the u's and v's and all that into our quotient rule. So dy by dx, so v, and then multiplied by u dash. So that will be sine of, sorry, not sine, it's u dash, isn't it? So 2 cos 2x multiplied by, it will be, sorry, v is minus 3 plus cos 2x. And then we are taking that away from, so I have to scooch over here a little bit. We are taking that away from u v dash. So u is sine 2x, v dash is minus 2 sine 2x. So that will give us minus 2 sine squared 2x. Let's get it with sine 2x times by sine 2x. And that will all be over our v squared, which will be minus 3 plus cos of 2x. So that is what dy by dx equals, like that. So I know that I want to set that equal to 0 then, because that means that when I sub in the x-coordinates of P and Q, that will satisfy that equation. Because remember, that's what the question was asking. We wanted to show that the x-coordinates of P and Q are the solutions to that equation, which they are the solutions to this equation. So we need to make this look like cos 2x is equal to a third somehow. So I think first of all, I've also forgotten to put the squared on here, haven't I? It's over v squared. Let's put the squared on there. There we go. That's what it should look like. So then I think I'm going to tidy up the numerator, and then see what I get. So let's do that. Let's tidy up our numerator. So we'd end up with 6 cos of 2x there, or minus 6 cos 2x, I should say. And then that'll be plus 2 cos squared x, cos squared 2x even, because it's cos 2x. And it'll be plus 2 sine squared of 2x, like so. And then that's all over minus 3 plus cos of 2x all squared. And that will be equal to 0. So I'm hoping now we can see there's a few things we can probably group together, I'm thinking anyway, because I've got a 2 cos squared 2x plus a 2 sine squared 2x. So let's think about sine squared plus cos squared is 1, is what I'm thinking there. So this thing in red, it's 2 lots, isn't it? We could factorize the 2 out. So that would equal, if I'm just putting it in red here, so 2 lots of cos squared 2x plus sine squared of 2x. And that'll just leave me with 2. It doesn't matter that it's a 2x there, as long as basically the x term, so cos x sine, as long as that bit's the same, it'll just become 1. So that whole thing in red just comes out to be 2. So therefore, I can now rewrite dy by dx now. I can now rewrite that. And that now becomes, so we still have our minus 6 cos squared x plus 2 over our minus 3 plus cos of 2x squared is equal to 0. Now, when I'm thinking about solving this, I need to think, well, how can I make that equal 0? Because if the numerator equals 0, the whole thing equals 0, doesn't it? So we can basically get rid of the denominator, because we know if we try and make the denominator 0, it doesn't work. You try and divide by 0, it doesn't like it, it doesn't work. So, therefore, we are dealing with just the top bit. So therefore, I can now say that, let me get my pen, I can say that minus 6 cos squared should be 2x, shouldn't it? Yeah, cos, oh, it is a cos 2x, not a cos squared, that's why I'm getting confused there. Cos of 2x, it looks like a square to me, that. Cos of 2x plus 2 is equal to 0. I'm just going to correct that up top as well. Just be careful with your 2x's and your cos squared x's. Just make sure that they're different and they don't look like each other, because that's quite easy to do. So I end up with this, and I can't remember what was I supposed to end up with. Let's go back and check. Cos 2x is equal to a third. Well, I think that looks quite promising. So let's just rearrange that a bit. So if I add the 6 cos 2x over, that becomes 2 is equal to 6 cos of 2x. And then divide through by 6, I get 2 6 is equal to the cos of 2x, which is the same thing as a third is equal to cos of 2x. So we've done it, because we set dy by dx equal to 0. We know that the solutions to p and q, the x coordinates of p and q would be solutions to that equation. So we made it equal to 0, and then we got the thing that it asked us to get. So that's part A of the question. And then part B, it says, hence find to 2 decimal places the x coordinate of the maximum turning point on the curve with that equation. So if y is equal to f of 3x plus 5. So that's our curve. So we can see the maximum turning point is Q. So that will be, when we get our solution for x, it will be whatever the biggest one is. And we know for the turning points are, as it tells us in the bit before, it's the solutions to that equation. It's the solutions to cos 2x is equal to a third. That will get us our turning points. So if I want to first of all figure out the turning points of f of x, so let's do that. So let's figure out first of all the turning points of f of x, because the idea is we can then think about the graph transformation that's occurred and then think about how that's going to then affect our turning points. So we have a third is equal to cos of 2x. So first of all, I'm just going to draw out what cos of 2x looks like. And our range, if you remember, is between 0 and pi. So I'm going to draw cos of 2x. So I'm going to draw cos of 2x between 0 and pi, wasn't it? So between x is 0 and x is pi. So let's do that. So remember, it's going to be a stretch, and it's a stretch of scale factor half. So that means I'm just going to do it up to pi for now. So up to pi, that means it's basically doing one period of a cos wave, because we'd have two lots in 2 pi, which would be normally what one period would be. So it's going to look like this. So here's my pi over 2, and so on. This would be pi over 4. This would be 3 pi over 4. So you might have a different method. This is the way I like to do this one. So in questions like this, so saying cos 2x is a third. So then let's find what 2x is by doing cos inverse of a third. And we're going to do it in radians because we're given our ranges or our domains in terms of pi's. So we're working in radians. So that gives me that 2x is equal to 1.23. And then x, if I divide that by 2, I get 0.62. Obviously, this is rounding to 2 decimal places there. So sometimes if you want to think about what pi over 4 would be as a decimal, just type that in your calculator. It's a bit harder when we've got working in radians and working in terms of pi. So pi over 4 is 0.785. So we know it's going to be x is 0.62. It's going to be somewhere like here. Only needs to be rough because we're just trying to figure out where the other solution would be within our range. Because remember, there should be 2 solutions because we've got 2 turning points. So we expect to find 2 solutions. So it's going to be like that. And you might use the cast diagram. So I like to use the symmetry of the curve to find that. So what I would do there is I'm basically going to say that this gap, I'm going to say the value of that is pi over 4 minus my 0.62. That's that gap there. So basically what I'm going to do is add that on to 3 pi over 4. Because I'm basically using symmetry of the graph and saying, well, I need to add that onto this side. So this x coordinate here will be 3 pi over 4 plus what we just worked out there, our difference. So plus that pi over 4 minus 0.62. And when I do that, that gives me my other value, which is going to be, I get 2.52 to 2 decimal places. So they are my 2 solutions. So x is 0.62 and x is 2.52. So remember, that's for f of x. And I actually don't care about the solution of f of x. I want to know what the turning point, if I go back to the question. So I want the maximum turning point for y is equal to f of 3x plus 5. The maximum turning point is the one further along. It's the bigger x value. So basically the q, the x coordinate of q is going to be that 2.52 there. So that's the value that we're interested in. But now we need to think about what transformation is happening there for y is equal to f of 3x plus 5. So we know f of 3x is going to be a stretch of scale factor a third. So it's going to, apologies, that's my phone. It's going to basically squish it. So we're going to get 3 periods in the space where we normally would have had 1. That's why I like to think about it. If you're squishing it, you get basically more of them. So if it's sine of 2x, you get double the periods within the same region. So if it's 3x, you get 3 of them within the same value you'd normally get 1 in. And then the plus 5 is just going to be a translation of 5 up. So that's, to be honest, this doesn't affect x. So that doesn't affect x. So we don't really need to worry about that. I don't know if it's affect or effect. But that doesn't affect x. I'm not bothered about that bit. So it's really just that f of 3x that I need to worry about. So I know this was cos of 2x, but now we're thinking about that graph transform. So one period happened in pi. Now one period is going to happen in pi over 3. And that makes sense because you think about the domain we're given here. We're given the domain of x is 0 and pi over 3, which makes sense because between 0 and pi, we get 3 periods now instead of 1 because it's 3 times smaller. So when we have 3x plus 5, I'm going to be quite lazy about this. So we're going to just draw our cos graph, but this time, this value will be pi over 3 now. So we just squished it. And then the plus 5, all my y values will go up by 5. As I said, I'm not really interested in that. That doesn't affect what x is. So basically, on my original graph where it was, it's now going to be divided by 3 now because it's been squished by a scale factor of a third. So that x of 2.52, I just need to divide that by 3 because now it's been squished by a third. So we now have 3, like I say, cos waves in the space of 1. So that gives me an x value of 0.84. So that will be the x coordinate of the maximum of y is equal to 3x plus 5. And if you want to, you can just write a little statement there. So I don't need to write that, but if you want to make extra sure that you're telling the examiner you know what that 0.84 is, then I would do that as well. But that is the question.